Hi, my name is Kevin Belk.
And my name is Brandon Turcotte.
Our project is on the analysis of salinity concentration and the per capita income of Hampden County townships. Salts are important compounds in the facilitation of life. They are needed to transport nerve impulses, contract and relax muscle fibers, and maintain a proper fluid balance. Salts are also used to prevent or de-ice roads during colder months. In the United States, the first usage of road salt was in New Hampshire in 1938, with an estimated 20 million tons of salt scattered on U.S. roads annually, or about 123 pounds of salt per American. Salts made their way into the environment during snowmelt or during rain events. Because of this, it has led to drastic increase of the levels of salinity and chloride measured in waterways across the United States, with about 37% of the total drainage area seeing a total increase in salinity over the last 50 years. The average salinity of freshwater environments is normally a concentration of 0.5 parts per trillion. Too much salt can result in negative or even sometimes severe health problems, such as increasing the work your heart and blood vessels need to achieve. Over time, this can stiffen blood vessels, which can lead to higher blood pressure, heart attack, stroke, or even heart failure. The question we asked ourselves was, how does per capita income influence a town's salt concentration? We had two alternating hypotheses. Our first hypothesis was that per capita income will increase municipal salt levels. Our second hypothesis was that per capita income will decrease municipal salt levels. Our experiment was to sample river sites and use regression to determine correlation.
So we selected 9 different municipalities based on data collected from the Massachusetts Department of Revenue. Under our criteria for testing locations, each one must have been bridged and have road access, but otherwise we chose them at random within each town. Field testing occurred the days following heavy snowmelt or rain due to the flow of water bringing the road salt into the ecosystem. Salinity was measured in millisiemens per centimeter using a Hydrolab Quanta-D, in which we carefully lowered into the rivers off the sides of the bridges. In order to do our regression analyses, we used the data toolpack option that comes with Microsoft Excel. Included is a picture of what the Hydrolab Quanta-D looks like, as well as 2 pictures of us in the field testing for salinity. Regression analyses for both per capita income and municipal revenue show that there was little to no statistical significance, although municipal revenue was much closer to being statistically significant compared to per capita income, with p-values of 0.71 and 0.21 respectively. Our R-squared values indicated that not much of the data can be explained by our current models, with only 5% of per capita income being explainable and only 33% for municipal revenue. Based on the data, per capita income does not seem to influence salt concentrations. However, there might be a larger connection with overall municipal revenue due to having a lower p-value and a higher R-squared value. There might also be connections with geography due to differences in soil porosity or in soil composition, which might have an influence in the environment. We recommend more studies, especially those focused on more townships or more focused in different geographic areas.